Chapter 10-4, Perimeters and Areas of Similar Figures. So if you recall the definition of similar, that means going from one figure to the other, the sides are proportional and the angles are congruent. Okay, Theorem 10.7, Perimeters and Angles of Similar Figures. It says if the scale factor of two similar figures is A over B, then the ratio of their perimeters is A over B, and the ratio of their areas is A squared over B squared. Okay, so scale factor is the same as the ratio of the sides. So when we say scale factor, we mean ratio of sides, and that's the same as corresponding sides. So let's say we start with the ratio of the sides. And that is going to equal the ratio of the perimeters. Okay, so if the ratio of the sides was A over B, the ratio of the perimeters would also be A over B. Now, if you want to find the ratio of the areas, you have to take the ratio of the sides or the ratio of the perimeters and you have to square it. Okay, you can square either one. So in the first case, we said the ratio of the sides and the ratio of the perimeters, let's say it was A over B. We have to take that and square it. Okay, so square it. And that's going to equal the ratio of the areas. All right. And when you square a fraction, you square the top and bottom individually. So that's going to be A squared over B squared in both cases. All right. So ratio of the sides, ratio of the perimeters, those are the same. But if you want to find the ratio of the areas, you have to take either one of them and square it. Problem 1, the trapezoids at the right are similar. The ratio of the lengths of the corresponding sides is 6 over 9, or 2 over 3. What is the ratio, smaller to larger, of the perimeters? All right, so here's the two figures that we're looking at. And they gave us the ratio of the sides. They gave it to us in the write-up and in the drawing. So the ratio of the sides is 6 to 9, but we can reduce that. 6 divided by 3 is 2, and 9 divided by 3 is 3. Okay, and we said a minute ago that the ratio of the sides is going to equal the ratio of the perimeters. So for the perimeters, just like the sides, the ratio is 2 over 3. So it's the same thing, it matches. Now for part B, they want us to say, what is the ratio of the areas? Okay, when they say smaller to larger, that means the first one is in the numerator. And the second one is in the denominator. Okay, smaller to larger, top to bottom. Anyhow, we're looking to do the areas. So before we said the ratio of the areas is the same as the ratio of the sides squared. All right, we already had the ratio of the sides, that's 2 over 3. So that's going to be 2 over 3. And that fraction is squared. Okay, when you square a fraction, you have to square the top and bottom individually. So that's going to be 2 squared divided by 3 squared. 2 squared, or 2 times 2 is 4, and 3 squared is 9. So this was the sides and perimeters, and this is the areas. Okay, let's look at got it problem number 1. It says 2 similar polygons have corresponding sides in the ratio of 5:7. What is the ratio, larger to smaller, of their perimeters? Okay, so remember that the ratio of the sides equals the ratio of the perimeters, and they said larger to smaller, so the larger number is going to be in the numerator, the smaller is in the denominator. So I set it up here. See if you can find the ratio of the perimeters for part A. Okay, so they gave us in the first sentence the ratio of the sides is 5:7. But they said larger to smaller, so larger they want in the numerator. So instead of 5 over 7, it's going to be 7 over 5. And for the perimeters, it equals the sides. The ratio is exactly the same. So that's it for part A. Now for part B, they want to know what is the ratio, larger to smaller, of their areas. All right, so remember, for the ratio of the areas, you have to take the ratio of the sides and square it. So please try part B and use your answer from part A. All right, so we have the ratio of the sides from part A. That's 7 over 5. So for the ratio of the sides, that's 7 over 5. But we have to square that. Okay, when you square a fraction, you have to square the numerator and you have to square the denominator. 7 times 7 is 49. 5 times 5 is 25. So that right there is the ratio of the areas. Okay, problem 2. The area of the smaller regular pentagon is about 27.5 centimeters. What is the best approximation for the area of the larger regular pentagon? Let's take a look. Okay, here are the 2 regular pentagons. And if I could give you the definition of regular, for a regular polygon, all sides and angles are congruent. So we've done that in the past. Also, you want to know that regular polygons with the same number of sides are similar. Okay, so let's say you have 2 regular triangles. Each interior angle is going to be 60 degrees, 180 divided by 3. So all of these angles are 60, and all of these angles are also 60. So notice one triangle is just a bigger or smaller version of the other triangles. All the angles are congruent and the sides are proportional. That's a definition of similar. So if you have polygons that are regular and they have the same number of sides, they're always going to be similar. Okay, so back to problem 2. They said the area of the smaller pentagon is 27.5. Let's write that in. So this is the smaller one. The area is 27.5 centimeters squared. And they are asking us, what is the best approximation for the area of the larger pentagon? All right, so we have this area, and this one here we do not have. All right, so we're looking to find the ratio of the areas first. Now, we know that the ratio of the areas equals the ratio of the sides squared. Okay, and we can see the ratio of the sides right here. So let's see, the ratio of the sides is basically 10 over 4. All right, so the ratio of the sides is 10 over 4. And we're going to square that fraction to get the ratio of the areas. Okay, now before I square the fraction, I would like to reduce it. It does kind of make things easier. So these are both even numbers. 10 divided by 2 is 5, and 4 divided by 2 is 2. Okay, so we're left with 5 over 2 squared. And when you square a fraction, you square the top and bottom individually. So the 5 gets squared, or the numerator, and the 2 gets squared, or the denominator. 5 squared is 25, and 2 squared is 4. Okay, that is the ratio of the areas. Okay, now that we have the ratio, we can set up a ratio and proportion with the area that we were given. All right, so let's set up two fractions. In the one fraction, I'm going to have the ratio. And in the other fraction, I'm going to have the actual area. Okay, we put the larger one on top. So we'll keep the larger one in the numerator, and we'll put the smaller one in the denominator. Okay, the ratio for the area we found was 25 over 4. The area of the larger one that's what we're looking for. Okay, we don't have the area of that pentagon. So we can call it X. And the area for the small one that was given in the problem, that's 27.5. Now, who knows what we can do at this point? Well, what you can do, one of the things you can do is cross multiply. Okay, top times bottom is going to be 25 times 27.5. And that equals bottom times top, which is 4 times x. The opposite of times 4 is divided by 4. And the 4's cancel. I'll do this on the calculator. And I get 171.875. Okay, they didn't say how much to round. However, I can see in their multiple choices that they don't have any decimals. So if we were to round this off with no decimals, just look at the first decimal. Okay, if it's 5 or more, you round it up. So the 171 becomes 172. Okay, and the units were in centimeters squared for the original area. So the new area is also centimeters squared. So that's going to be X, but we said X was your area. 172. So that is answer C. Okay, let's look at got it problem number 2. The scale factor of two similar parallelograms is 3 over 4. The area of the larger parallelogram is 96 inches squared. What is the area of the smaller parallelogram? All right, I'll give you a few hints. First of all, for scale factor, that is the same thing as the ratio of the sides. Okay, so that's what they mean by scale factor. They have to be corresponding sides. And they say the ratio of the sides, or the scale factor, is 3 over 4. And they want us to find the area of the smaller parallelogram. The larger one is 96 inches squared. So let's set it up. Okay, the ratio of the areas is going to equal the ratio of the sides squared. So the ratio of the sides is 3 over 4. You're going to take that and square it. Please try that first. All right, so if we take the ratio of the sides, that's 3 over 4. And that's squared. Okay, individually, that's going to be 3 squared over 4 squared. 3 times 3 is 9. 4 times 4 is 16. Okay, that's your ratio of the areas. Now, just like last time, we're going to set up 2 fractions. All right, one fraction is going to be the ratio, and the other fraction is going to be the area. Okay, we can see the smaller number was on top, and the larger number is on the bottom. So someone please tell me what goes here for the ratio. Well, the ratio of the areas we already found. That's 9 over 16. Okay? And now, they gave us the area of the larger one. They said it was 96. So the area for the larger one is 96. And the area for the smaller one is what we're trying to find. So that's x. Please try and finish this. Okay, you want to cross multiply. Top times bottom is 9 times 96. Bottom times top is 16 times x. The opposite of times 16 is divided by 16. You have to do that to both sides. It cancels here. I'm going to do this on the calculator. 9 times 96 divided by 16. And I get x equals 54. Okay, the units were in inches squared for the original area. So the new area is also going to be inches squared. Okay, problem 4. The triangles at the right are similar. What is the scale factor and what is the ratio of their perimeters? Okay, once again, for scale factor, we know that's just the ratio of the sides. Okay, so try to remember that. Okay, so here we're given the ratio of the areas, and we have to find the scale factor or the ratio of the sides. All right, so that's what we're looking for. So remember in the beginning we said the ratio of the areas equals the ratio of the sides squared. But if we take the square root of both sides, when you take the square root of something squared, that's just the original number. Okay, so the square root of the ratio of the sides squared is just going to equal the ratio of the sides. So the ratio of the sides is going to be the square root of the ratio of the areas. Okay, and the same is true with the perimeter. You take the square root of that, and you end up with the ratio of the perimeters. All right, so the square root of the ratio of the areas equals the ratio of the sides equals the ratio of the perimeters. So if we want to find the ratio of the sides, what we have to do is take the ratio of the areas and take the square root of that. And that'll give us the ratio of the sides. All right, so it's not too bad. So the ratio of the areas we can just say that's 50 over 98. Now, before we do anything to that, it could be easier, it could make things easier if we reduce. So 50 divided by 2 is 25, and 98 divided by 2 is 49. Okay, these were both even. That's why I divided by 2. So the ratio of the areas is 25 over 49. Okay, ratio of the areas is 25 over 49. So the ratio of the sides is going to equal the square root of the ratio of the areas, which is 25 over 49. And when you take the square root of a fraction, you do the top and bottom, or numerator and denominator, individually. So that's the square root of 25 over the square root of 49. Square root of 25 is 5. Square root of 49 is 7. And that is the ratio of the sides. Now, they also want the ratio of the perimeters. However, we said it a minute ago that the ratio of the perimeters equals the ratio of the sides. And we just found the ratio of the sides, which is 5 over 7. So same thing. Perimeter ratio, side ratio, same thing. Okay, please try got it problem number 4. It says the areas of two similar rectangles are 1875 and 135. What is the ratio of their perimeters? Okay, I'll give you a hint. We said the ratio of the perimeters equals the square root of the ratio of the areas. So if you just make this into a fraction, try to reduce it as best you can and take the square root. See if you can get it. All right, so the ratio of the perimeters is going to equal the square root of the ratio of the areas. So the ratio of the areas is going to be 1875 over 135. And we need to take the square root of that. Now, before I do any square root, I am going to reduce. Okay, so let's work on that a little bit. These both end in a 5, so I'm going to do 1875 divided by 5, and I get 375 for the numerator. And 135 divided by 5 gives me 27 for the denominator. Okay, if you add the digits and they are divisible by 3, then the original is divisible by 3. 3 plus 7 is 10, plus 5 is 15, so I can divide this by 3. Okay, 375 divided by 3 is 125. And 27 divided by 3 is 9. Okay, so we're left with the square root of 125 over 9. Okay, so this is actually a tough one to simplify, but we know that 125 is the same as 25 times 5. And the square root of 9 we have in the denominator. Remember, when you take the square root of a fraction, you do each one individually. All right. So the square root of 25 is just 5. Okay, so that's just 5, and we have radical 5 left over. And the square root of 9 is 3. So that is your final answer. All right, that's a tough one, and I'll try not to give you any quite like that on the homework. Okay, but 5 radical 5 over 3 is the ratio for the perimeters. If you didn't want us to take if you just wanted to leave it, it would be radical 125 over 3, but same thing.